Hello again, I'm Brian Jenkins, and I hope everyone here is having a great day. Now that we've conquered libraries, we have one more important programming concept to cover before we roll up our sleeves and do some hands-on stuff and learn about things like LCDs, servo motors, and more. We need to talk about interrupts. Now, I'm not talking about being rude during a conversation, as we'll see. An interrupt is a communication process in a microcontroller where an internal or external device requests the microcontroller to stop processing and attend to the request. This can happen at any time, and it happens because some tasks take priority over others. To illustrate, pretend you're boiling a pot of water in the kitchen. By staring at it, you think that maybe it'll boil faster, so you sit and watch while it reaches the boiling point. But then your phone rings, and it's important, so you stop and answer it. Your cousin tells you the Amazon guy accidentally delivered your new big screen TV to his place. When you're done uttering four-letter words, you tell him you'll pick it up tomorrow. Then you go back to watching the water. It's kind of like that. Up until now, we've been writing code that executes one line at a time sequentially, like this. And this step-by-step approach has served us well for the simple sketches we've written so far. The problem is, though, that for some applications, doing things this way can be inefficient and even downright dangerous. This is because, as we mentioned, some tasks have a high priority while others have a lower priority. Let's talk about a more practical example to illustrate this concept. Say you've spent weeks toiling on a really awesome Arduino-based home automation system. I mean, this thing does everything. It keeps the temperature exactly where you want it. It automatically opens and closes the blinds. It adjusts the lighting for you, and more. And you were even smart enough to include a security system and fire detection capability. So, one day you're sitting down working on your next great Arduino-powered creation when the fire alarm goes off. Now, obviously, you wouldn't say to yourself something like, "Geez, I'm kind of busy right now. I'll get to this in about 10 minutes when I finish what I'm doing." No. You'd immediately stop whatever you're doing and try to put out the fire or call the fire department. And of course, you'd want the alarm to sound as soon as the sensors detected even the smallest flame or bit of smoke. This is obviously a very high priority. But here's the problem with programming your home automation system the way we've been programming our other sketches. When the sensors detect fire or smoke, the program could be at any point in the code. In other words, our system may be checking or adjusting the thermostat temperature. Or maybe it's checking to see if it's dark yet so it can close the blinds. Or maybe that coffee maker you wired into the system is brewing a fresh cup right now for you. So, let's say it takes 10 seconds to check and adjust the temperature. And it takes 5 seconds to check if it's dark. And if it is, we need another 30 seconds to slowly close the blinds so they don't break. Then our perfect cup of coffee takes 10 minutes to brew. And our other functions also take time to execute. Now, you get the idea. Who knows when it will get to the line of code that checks the fire sensors? It may be right away, or it could be several minutes depending on how complex your home automation system is, where it is in the program, and what the program is doing. This is obviously a problem and a safety hazard if a fire starts or someone is breaking in. So what can we do to deal with it? Well, maybe we can have it check the fire sensors more often, like every third line of code or something. Now, this can improve the response time if a fire does start, but it still doesn't guarantee an immediate response, and there's a better, more efficient way. What if we move the code that deals with the security system to the top? Well, we'd have the same problem, because a fire could start right after we just checked the sensors. Then we need to wait for all the other code to execute before it came back to the top. So, just as you would immediately stop whatever you're doing if you heard the fire alarm and go and deal with it, we can have the Arduino do the same thing. The fire sensor would trigger an interrupt, which would cause the Arduino to stop whatever it's doing and jump to some other code known as an interrupt service routine, or ISR for short.